before. This is just an introduction. So what this is I will give an introduction to the basics, the technical basics, and we can have a more in-depth discussion and training during the bootcamp. So for now, I will limit myself to the actual technical functionalities that you will need. The real implementations can be discussed later. I'll just give some quick pointers here. Excuse me. So, sorry. Why are we setting up a data space? I think my colleagues sufficiently introduced this. We already discussed this as well as the positioning towards the other data spaces. Sorry. So I would like now to define the concept of the building blocks. These building blocks were defined firsthand by the DSSC, so the Data Space Support Center, and customized and tailored towards communities through the DS4SSCC preparatory action. So the building blocks that we refer to are accessible on the inventory. And they will contain already an overview of industry standards, specifications, and implementations that you can use, as well as their links to potential minimum interoperability mechanisms and some guidance on best practices. There are, within the data space blueprint, there are technical and non-technical building blocks. For this introduction, I will focus on 9 technical building blocks organized in 3 pillars. This is the overview of all the building blocks. So we see that they're organized in 3 pillars. On the left-hand side, we see data interoperability. This is all the building blocks that are related to actually being able to share data. The middle pillar is related to data sovereignty and trust, which means everything that has to do with the identification and authorization of participants to the data space. And then on the right-hand side, we have data value creation technical building blocks, which are building blocks that would help you to realize the value that Flavio just discussed in terms of a business model. We'll start from the right, because of course, the most important thing is that you are able to create value from the data space. So let's dive straight in. So the goal of the data value creation pillar, as defined through the DSSC, well, I won't read it for you, is just quickly to generate value and for participants to be able to enter into a data sharing relationship. This is an overview. So the first building block is related to the actual offering descriptions. So within your data space, you will be offering either data sources, but also potentially data services, and of course for them to be. Sorry, Taylor just muted you. Sorry for that, because I had an echo. I don't know where you are, but it looks like it makes sense for me to have an echo there. So the second building block here is on publication and discovery. How would you publish all these services in order for other people to discover them? And then finally, a quick introduction to what value creation services might be. The first building block, its goal is to have a description of your data sets or services. And this description may include various kind of attributes. Your participants will select a data source or a service potentially based on, for instance, geographical location, but also because of the terms and conditions that it might have. This technical building block will also provide some metadata on how to actually access the service or the data source, including ideally an endpoint URL. It might also include the operational metadata, such as attributes such as description, the creator, the prices, the pricing, the license, any kind of licensing or SLAs that may be relevant to the service or the data source. So quick recommendations. You will receive the slides so you can go through them yourself if you wish to prepare. But I want to go too deep into this, just knowing that there are standards for general metadata and application domain specific ontologies that we would recommend you to use. As for the discovery part, it is essential that within your data space, participants provide a catalog of the services and the data sources that they are providing. A catalog, very simply, is a listing of assets that you wish to make accessible within the data space. And for this, we recommend using the DCAT standard and its many application profiles. And we would also recommend a cost-effective way of implementing this catalog, for instance, through using CCAN or any other data cataloging systems you already have in place. What are these value creation services? I just want to take a moment here to think about these, because we often say that, okay, data is the new gold. Combining and refining data creates value. That's all very true. But there are many other kind of services that you might provision within the data space. These services are not necessarily limited to actions that transform or analyze or generate data. They might also be any other kind of thing, technical things, such as, for instance, just providing compute power or provisioning a virtual machine on which you can work with this kind of data. So data enrichment services, all these kinds of things are considered to be value-added services within a data space. Some recommendations, of course, it's important to think for each of the participants how they will create value, or in order for there to be an actual value proposition in the data space, such just as Flavio just detailed. Then we head over to the entire left-hand side of the technical building blocks, and we go into the data interoperability pillar. These building blocks provide resources to create a data offering that is interoperable. Of course, it's very important to do this because there is no use in provisioning a data source that nobody knows what it's about or cannot use in their system. So interoperability really is key in order to make the data space work. We identify, again, 3 technical building blocks. The first one are data models. The ways in which you would describe metadata about the data, not limited to operational metadata as we just saw, but also actual semantics for the individual data sources and the individual data points within those data sources. You will also need to provide data exchange capabilities. How to access this data, how to access these data sources that might not be limited to using an API, as we will see later, and some means in order to provide provenance and traceability, making sure that you can trace who is accessing your data, and if the data is unaltered, where it comes from, what is the process for this data to be released, and so forth. Very quickly, data models, I think most of you will be familiar with the concept, is basically the capability to add semantics to any kind of data point. So what does this data mean? That can be done through metadata, it can be done through linked data, but not necessarily. We identify different ways to provide this kind of semantics. A very important recommendation here is that there are so many ontologies and data models out there right now that it often does not make sense to build your own. Still, in many projects and data spaces, we see that a lot of data providers consider their data to be unique. That might be the case in some very specific niche cases, but please reuse what's out there in order for this data to be easily found. Another important recommendation, of course, is there is a minimum interoperability mechanism working group for data models. It is MIM21 representing data. We would warmly invite you as pilots to join this working group and also share your experiences, because this is what helps us create an interoperability space within Europe. Then for data exchange, as I mentioned, this is a way to have agreed mechanisms to exchange data between parties. The Data Space Support Center mentions the creation of a rule book for data space, and transmission is not necessarily simply providing an API. It might also be streaming data, subscription, PubSub-based data, WebSockets, and so forth. So it's very important to think about the right transmission method for your use case and for the data type that you are actually providing. Quite a lot of technical recommendations that we will go into later. Provenance and traceability. This is important for partly for security. So you need to know that your data has not been tampered with, that its integrity is intact. But it also provides some ways to detail the business process behind the creation of the data, the intended use of the data, who is the owner, or how many different owners, how many hands this data has gone through. These are all provided within this technical building block. All right, and then we arrive at the third and final pillar, the data sovereignty and trust pillar, which is about really creating a trust network within a data space and making sure that all the participants of the data space are who they claim to be. And these technical building blocks provide means in order to install this trust network. Again, it consists out of 3 building blocks. The first one is on identity and attestation management. There's different ways, of course, to identify people. Typically within data spaces, we will have decentralized identity management, which is not that easy to set up, but is actually a requirement if you want to have an organically or let's say a federated data space that can expand without human interaction. There is a trust framework, so any kind of mechanisms that you would need to verify that any participant will adhere to certain rules. And then there are access and usage policies enforcement, which differs from the previous building block in the sense that this is related specifically to certain data offerings or service offerings that might have usage policies on them. And there are different means how to encode and formalize these usage policies to know which participant can access which resource in which way. So identity and attestation management in order to identify data space participants and ideally doing this in a self-sovereign manner. The DSSC recommends the creation of a conformity assessment scheme. That means that there is a scheme through which anyone can, be it automatically or be it through human intervention, make sure that any participant is conform the requirements of the data space. The DSCC also recommends the use of verifiable credential and decentralized digital identities. And there is some documentation here on trust anchors, service providers, and very important as well is to describe the actual life cycle management of data space participants. The classical technical implementation of identification is centralized through identity providers, using or identity providers and maybe setting up a single sign-on environment. These are typical technologies in order to do that. To have decentralized identity management, we want to move through to technologies that are here on the bottom of the slide, such as decentralized identifiers and verifiable credentials, and some related protocols in order to install and verify them. Quick recommendations. Most of the pilots will have centralized identification in place. It is very important to build on top of this. So already you can start identifying within each of the parties within each of the pilots, which are the let's say the trust registries, which are the account lists that you want to be using. Would you set up a new one, or would you have one governing authority within a pilot data space? And well, similar discussions you can already start having within the pilot right now. Then the second building block here is the setting up of trust framework. So this is actually after any participant has been identified and it is proven that it's conforming to the conformity assessment scheme. There also needs to be a way to authorize and have different kind of roles and capabilities defined for each of these data space actors. There might be different kind of roles, so not every participant is created equal within a data space, but it's also dependent, of course, on the type of pilot or the type of data space if you want to have different categories of participants. This building block provides, for instance, this conformity schema, which will allow, which details different ways of ideally automatically checking if any of the identified participants conforms to a specific role or a specific capability. Recommendations: keep it simple, as little requirements as possible. Don't have an overcomplicated hierarchical rights and rules kind of structure, because all of these will have to be documented and formalized quite rigidly. So limit the number of roles of participants to maybe one or two, or worst case three types or classes of participants. Then last but not least, of course, this is where everything comes together. This is the access and usage control policies that are described on a data source or a resource or a service level. Again, there are different ways to do this. When any participant tries to access any resource, there might be a specific decision context. How are you going to find out if the context of usage is applicable right here? There might be issues of consent management. If all of this is managed, then you still need to know if a participant is legally authorized to access the resource. So this might be based on contracts, licenses, or code of conduct. And then finally, you will have a technical agreement negotiation. So ideally, this is a kind of a machine readable kind of negotiation or a smart contract that can be enforced between the data provider and the data recipient. Typical implementations for this are role-based access control or attribute-based access control. Implementations might be key-lock or key-cloak. ODRL is a language to encode these kind of different roles, and OPA, or the Open Policy Agent, with its own kind of role formalization language, RIGO, are often very often used in this context. Again, our recommendations are to start by writing it out on paper, basically, drafting up the conformity scheme and drafting the legal requirements. Before implementing any of these authorization technologies, clearly document on paper the different categories and roles and types of interactions that you want to be able to organize within the data space. And also, as we mentioned earlier, try to find out already from the start which identification and access management tools any of the parties within the pilot already have in place. because setting an entirely new directory of users, or a trust registry, as we call it, up in the short time your pilot will run might be complicated. Okay, I think we have some time for questions.